All right, this is a quick discussion following our TA meeting for homework 7, question 3, part A. So if we have something like 3 plus 4s or 3 plus 4j omega, and we're trying to plot it in the Bode plot or in a log plot. We're trying to plot the magnitude and phase. So we start by putting it in like a standard form, in which comes 3 times 1 plus 4 over 3 s, or we can use as well 3 1 plus 4 over 3 j omega. So solving for the magnitude, first of all, the advantage of using a log plot is that multiplication becomes addition. So this can be divided into two functions, g and h, where the magnitude total is the sum of the magnitude of G plus the magnitude of H. So let's solve for the magnitude of G equals, 3 magnitudes equals to 3, and angle of 3 equals 0, or angle of G equals 0. So converting it into the form we need for the Bode plot, which is 20 log 10 times magnitude times magnitude of 3 times, which is 3. I think it's 9 point something, 9.5, probably 9.5 dB. And the angle is 0 radians per second, or 0 degree. For my second part, which is H, magnitude of H equals, as we are familiar, you can use the forms provided in the notes. Your life will be much easier, but for explaining the process, we just solve for the magnitude the way we are used to. So equals 1 squared plus 4 over 3 omega squared, 4 over 3 omega squared. All right. So then you can make a table. Values of omega and values of magnitude of H. So when omega is equals to 3 over 4, so this whole thing is 1. So when omega equals 3 over 4, this is referred to as the breakout point, I think, or omega C, those multiple things. So this becomes root. So omega equals 3 over 4. This is 1 squared equals 1, and this whole thing will be 1 squared as well. So equals to root 2, which is the small value. So it becomes root 2. You can as well solve for converting it into a Bode plot. So taking 20 log H, 20 log of H, which is 20 log of root 2. And so we did it in MATLAB, 3 point something. So it's for 3. Please just check the forms and the lecture notes. They are much clearer. Then, so this is my W. Now, this is referred to as WC. So when W is 10 times WC, when W is 30 over 4, you can as well solve for H and solve for 20 log H, and so on. Let's plot it and see if there is. So let's plot the magnitude plot. Our first plot is that of G, which is 3, which is equals 9.5 dB. So 9.5 dB, and it remains 9.5 dB. My second plot is of H. So at 0.3 over 4, 3 over 4, the value is actually 3. But we usually, since it's the breakup point, we can refer to it as 0 with slope of 20. So slope equals 20. And to prove the slope, if you got the second step, if you got omega equals 30, since the both plot is in decibels in tens, so this is my next step. Omega equals 30, you will solve for H and solve for 20 log H. You'll find that the change is almost 20. So it'll probably be something, it will be like 23 or something closer to it. So this is the approximative result of the two plots. Then adding them together will give you something like so at 9.5. Your signal starts at 9.5, then it comes to 0.3 over 4. Your signal will, adding those two values, adding 9.5 dB plus signal uh, with 20 slope, you'll have something like this. So this is your total H of j omega magnitude. Here that's 3 over 4, which is 0.75. 20 dB. Same thing for the phase. So getting the phase of 3 equals to 0. Getting the phase of H. Let's change our color back. Getting the phase of H, we can write it here. Phase of H of j omega equals tan negative 1 of the imaginary part, which is 4 over 3 omega over 1, which will become 4 omega over 3. So let's plot the phase of both elements. So the phase of the first element is 0, so it will not have any effect. The phase of our second element, which is h of j omega, let's plot it. I can change the color. So, or we can draw our table as well, which we have omega, phase of h, and that's it. So when omega equals 3 over 4, which is the breakout point, so tan 1, I think it's 45. And when omega equals, so we can try values of 10. As omega grows, omega, let's say we can make it 10 or 20. So tan 40 over 3 is closer to 90. So as omega grows, the value gets closer to 90. So the phase plot will become something like it starts with 0, or so let's make this point 45 degree, and this is 45. 0 degree and 90 degree. So at 3/4, our phase will be 45, and at 30/4, your phase becomes closer to 90. And as you get smaller, the value becomes smaller exponentially as well. So your phase plot will look something like this. You're getting closer to 90 as you grow and getting closer to 0 as the value reduces. The more values you put, the more properly your phase and magnitude plots will look like. You can use forms, the 4 forms in the notes, but this is just trying to solve it manually. This is your magnitude plot, and this is your phase plot.